Every time you take a pill, you're basically making a calculated bet. But what are the real odds? Today, we're going to pull back the curtain on the science of risk so you can understand what's really at stake with the medicine in your cabinet. Let's dive in. But first, I've got to ask you something. Just think about your day so far. From crossing the street to whatever you ate for lunch. Is any single part of it completely 100% free of risk? It sounds like a simple question, right? But the answer? Well, it's actually pretty complicated, and it gets right to the heart of what we're talking about today. And to really get a handle on that question, we can't just go with our gut. We need to start with a clear, scientific understanding of what the word risk actually means. So let's get on the same page and define our terms. Okay, so here's the crucial point. Risk isn't about certainty. It's about chance. It's the probability, the likelihood that something you don't want to happen could happen. Now keep that idea of probability in your head because it is the foundation for everything else we're about to get into. All right, so risk is about probability, but what shifts those probabilities? What makes a bad outcome more or less likely? Well, that is where risk factors come in. You can think of them as the ingredients that can totally change the recipe of risk. And the timing here is super important. A risk factor is a pre-existing condition, or something you're exposed to that makes you more vulnerable before a problem even shows up. And these factors, they can be temporary or, they could be with us for our entire lives. So where do these things even come from? Well, turns out they're kind of everywhere. They can be really personal, like our genetics or our habits. They can come from our family, our community, and even really big picture things like institutional policies or environmental pollution. It's a really layered thing. And this right here, this brings us to probably the single most important and most misunderstood idea about risk. It is absolutely, positively not a guarantee. So let's really break down the difference between a probability and a promise. Think of it this way. Walking across a tightrope definitely increases your risk of falling, right? But it doesn't guarantee you're going to fall. Being exposed to a risk factor is just like stepping onto that tightrope. The odds have shifted, the probability's gone up, but it is not a done deal. Let's make this real for a second. Even with a really powerful risk factor, like the drug thalidomide, the outcome was different for different people. Same goes for psychological stress or being exposed to lead. So why is that? It's because these risk factors interact with our totally unique biology, our genetics, our environment. It's all incredibly complex. No two people are the same, so no two responses are going to be the same either. And another thing, not all risks are created equal, not by a long shot. Some risk factors are just tiny little markers, while others are massive, life-threatening red flags. This huge variation in severity is a really key part of how we evaluate and manage risk. So if risks can be anything from a minor inconvenience to a major emergency, how on earth do we decide which ones to take? Well, that brings us to what you could call the personal spectrum of risk, where our own choices, our perceptions, and just the context of our lives all come into play. Let's kind of walk along this continuum together. On one end, you've got risks you have zero control over, like your genetics. Then you move along a bit, and you find risks you might reluctantly accept, like something you're exposed to at work. Further down the line, you have risks you freely accept, lifestyle choices. And way at the other end, you have risks we actually seek out, like investing or playing competitive sports. We are all moving along this continuum every single day. Okay, so we've talked about what risk is and how we think about it, but let's switch gears. How do scientists and researchers actually try to measure it objectively? How do they turn this really complicated idea into a number you can actually work with? So the holy grail for researchers is to find something called the true risk, the actual real-world probability of something happening. But, and this is a big but, there's a catch. We can never actually observe it directly. It's an ideal. So instead, we have to estimate it, and that whole process is just filled with challenges. One of the biggest roadblocks is something called bias. Now, in science, this isn't about personal opinions. It's a systematic error, a flaw really, in how a study is designed that can totally skew the results. For example, if you're testing a new drug but you only include healthy young adults in the study, well, your results are going to be biased. They won't tell you anything about the risk for an older person with other health problems. And then there's its tricky cousin, confounding. This is when some hidden third factor comes in and messes up your results. The classic example is the old belief that drinking coffee caused heart disease. Well, it turns out that a lot of coffee drinkers also used to smoke. So it was the smoking, that's the confounding factor, that was the real culprit, not the coffee. So, how do researchers navigate this minefield to get a number we can actually use? Well, they start with that theoretical idea of true risk. Then they design these incredibly careful studies to try and control for all that bias and confounding. They apply really powerful statistics to their data, and what comes out on the other side is the estimated risk, their best possible guess at that hidden, unobservable reality. Okay, I know, that was a lot of science. But here's where the rubber meets the road. How does all of this connect back to you and that bottle of pills in your medicine cabinet? Let's bring it all home. Here is the bottom line, and it is so important. No drug is 100% risk-free. It just doesn't exist. Every single medication is a balancing act. It only gets approved if its proven benefits are judged to be greater than its potential risks. It is always, always a trade-off.
And critically, that risk profile isn't one size fits all. It is intensely personal. The risk of a drug for you depends on your age, your health, your lifestyle, what other medications you might be taking, even how your individual body processes the drug. Risk isn't some static number, it's a dynamic reality that is completely unique to every single patient.
All right, let's just do a quick recap of the big ideas here. First, and say it with me, risk is a probability, not a promise. Second, risk factors are all around us, from our genes to our zip code. Third, we are all navigating a personal risk continuum every single day. Fourth, those risk numbers you hear about are really just well-informed estimates, not absolute truths. And finally, drug safety is always, always about balancing the benefits against the risks. So I'll leave you with this final thought. The next time you see a commercial or read a label that lists a bunch of potential side effects, you now have a much smarter way to think about what that actually means. It's not a promise of what's going to happen to you, but a probability to be considered and weighed. How is that going to change the way you think about your health? Thanks so much for watching.